All right, good morning, students. So this is part two of the lecture on the Kalam cosmological argument. Just to refresh our memory, the argument is a syllogism. That means it's an argument with two premises and a conclusion. That can be expressed like this. Whatever begins to exist has a cause. Remember, I said that if you don't like, for some reason, the idea of the causality, we can free the premise from causality by saying that everything that begins to exist needs something or someone to bring that thing into existence. I think this is pretty clear. As I said, for example, this glass is not eternal. It began to exist at one point. But who made it or what made it? Someone must have made it. That's the rule. We don't know anything that begins to exist like that, like babies, pizzas, bread, glasses, schools, and there's no cause whatsoever, or there's no agent, person, or thing that brings that into being. The second premise is the universe began to exist. We left off at that point. Therefore, the universe has a cause, or the universe, again, if you want to rephrase it, the universe was brought into existence by something or someone. Remember what I said about premise one. It seems that it doesn't require, some people argue that the first premise is false. I said that the first premise seems to me, perhaps you don't want to totally commit to premise one, but it seems to me pretty obvious that whatever begins to exist has a cause, because out of nothing, nothing comes. It would be more than strange, absurd, that something, anything, even a particle, even a subatomic particle or a string or a vibration, anything, came into being out of nothing. What is there to produce this thing? People who say, well, it just pops into existence out of nothing. Well, you actually need a universe in order for anything to happen, as we know. Even subatomic particles that pop into existence, allegedly, out of nothing, they require a universe. Some people say that quantum particles can come into existence and go out of existence for no reason whatsoever. Well, but we have a universe, so it's not that there's nothing at all. So imagine, actually I always say imagine, you can't imagine nothingness, because it's nothing. We can't even intelligently talk about nothing. But just suppose you could imagine nothing at all. No energy, no space, no time, nothing. What could possibly have the property necessary to bring into existence a thing? Exactly. Nothing. So as I said, premise one, it seems to me, true, beyond reasonable doubt. But if you want to doubt it, it seems to me that you have to deal with this problem. What's more plausible? That a particle or a glass or a tiger comes into existence out of nothing at all? Or is it more plausible that whatever begins to exist was brought into existence by something else. It seems to me that the more plausible premise is that things don't come into existence out of nothing. So the first premise is true. So we were looking at premise 2. And if you recall, premise 2 has to do with the difference between actual and potential infinity. In other words, the way I explain this is the following. As you can see here, this is today. We are here today. This is the past. This is the future. Now, in the future is open to us. We don't know how long it's going to be. So in the future, if I ask you, how many days, for example, are in the future? Well, the days are potentially infinite in number, because you add one after another and you get a potentially you go toward infinity. If nothing happens to the universe, you could count forever. But notice the important thing here, that in this sense, the number of future days of the universe is potentially infinite, and it grows. So tomorrow is not here yet. So from the point of view of today, tomorrow is going to be a different day. And the next day is going to be another day, a different day. And the number of days will grow. A new day will become available, will occur, or will be created, if you like that. But a new day is going to be available the next day and the next day in the future. Okay, so the number of days will continue to increase, and you will have always one more day. So if you let's put this in terms of a collection. Let's say that you have a collection of stamps or a collection of coins or any sort of collection. CDs, who collects CDs anymore? But anyway, suppose you have a collection. As you buy new coins or new stamps, you acquire new stamps or new CDs or new whatever you want. Your collection increases, okay? But think about this. While your collection increases, it is always possible to add one more member to your collection. So if you have 300 million trillion stamps, let's say, that's not the end of it, because you can always acquire a new one and add it to your collection. So your collection is not complete. But when is it complete? Well, essentially, never. It will never be complete. Because if you have future days to come, you may acquire new items and add them to your collection. So it will never end. This is obvious, right? It's obvious. Okay, so now this is the idea of the notion of potential infinity, okay? Now, when we look at the past, let's look into the past, okay? Right here. Now, in the past of the universe, okay? In the past of the universe, the days, if we want to divide it into days, okay? The days in the past history of the universe do not grow. So if you conceive, if we assume or we use this idea of a collection, let's say that this is a collection, okay? the past days in the universe form a collection, let's say. But notice that this collection, unlike the future collection, this collection, the past collection, does not grow. Why doesn't it not grow? Because it's not like we are acquiring a new day. I know what you're thinking. You're thinking, but tomorrow is going to be a new day. No, but that's the wrong way to look at it. Think about it from today or any arbitrary day, okay? Say, so March 12th. From the reference frame, from the point of reference of March 12th, for example, the days in the future will grow. It's going to be a new day as time progresses. But from March 12th, once again, the days in the past are not growing. They already happened. They have already happened. They are already there. This is simple, right? They're already there. It's not like you look back in the future, and as you look, your collection of days increases, grows. That's impossible. The past has already passed. It's done with. Okay? So the kind of infinity that we need for the past days of the universe as a collection is not the potential one, because potential means an infinite number of things that grow in time. Actual infinity, I know that this might sound confusing to you, but actual infinity is a mathematical concept. In mathematics or in logic, for example, you have things called sets. Okay, a set is a collection, is a family with many members that contains certain members. And in that set contains not a potential infinite number of things, but an actual. Yes, but what does it mean, actual? Well, it means that the collection doesn't grow. The collection is done. The collection is complete. You don't add any more members to the collection. And as I said, it doesn't make sense in life if you think about it, because how could you possibly complete a collection? Let's say that this next Christmas, Santa Claus will bring you the gift of immortality. So you now are immortal. And let's assume that the universe will go on forever and ever and ever. You see, I don't care how much time you have. If you want to acquire a collection of stamps, you will always buy a new one and a new one, but you will never, ever get to the last one, the infinitieth stamp that you can say, finally, whew, I made it. This is the last stamp and I'm done with my collection. Now I have an actually infinite number of stamps. Well, that's impossible, because it's always possible to add one more, and one more, and one more after that. So a collection of things, any collection, any number of things in the real world, in this world, I'm not talking about mathematical concepts, in this world, in the universe, there's nothing that, no collection of things can be infinite and complete at the same time. In fact, it doesn't make sense to say that. It's just absurd to say that a collection is infinite but at the same time is finite, because it's just a contradiction in terms. And as I suggested, only in mathematics can we make sense of an actual infinity, a collection that is complete. So, for example, if I say that I'm considering the collection of all even numbers, that collection doesn't grow because I conceive all the numbers, all of them, all the even numbers. And so that collection, mathematically speaking, conceptually, is a complete collection. It's not growing, it's complete, it's given all at once. That's the only way to make sense of actual infinity. But now, I don't want to lose focus of our discussion here. Why am I so obsessed with actual infinity? Well, again, as I pointed out in the first video, we have a problem here. The problem is, remember that we are trying to establish that the universe is not infinite. It's not beginningless. It's not eternal. And how do we do that? Remember, I suggested, in order to do that, let's assume that the universe is infinite and ask ourselves, what would that mean for the universe to be infinite? And the answer is, it would mean that the days in the past of the history of the universe are actually infinite. You see, that was the problem. But why is that? Well, once again, because you can add one more day as you go in the future. That would be potential infinity. But you can't add any days in the past. The past has already happened. So you can't modify the past. And so if the past has already happened and it's there, and all those days in the past of the universe are there, then, and the universe, we assume, is eternal, then it must be that the number of days in the past of the universe is an infinite number, but an actually infinite number, not a potential one. But that, as I said, is a problem, because nothing can, in the world, no collection in the world, whether it's a collection of stamps or whether it's a collection of days, the point is still the same. No collection can be actually infinite. Okay? And now, I want to demonstrate with the next example how it is impossible that a collection, any collection, can, in the world, can be actually infinite, besides, okay, with the exception of mathematical collections. But those are conceptual. They're not actual, they're not real. So the way that William Lane Craig explains this in his paper is by using the famous Hilbert's hotel paradox. David Hilbert was a mathematician, and he came up with this paradox precisely to show what I'm about to show, and that is, as I said many times, that an actually infinite number of things cannot exist in the world. So the best that you can get is a potential infinity, one that keeps growing. An actual infinity is a number of things that is infinite but is not growing. So in order to explain why an actual infinite number of things cannot exist, David Hilbert proposes this hotel paradox. So imagine there's a hotel that has an actually infinite number of rooms. But wait a minute, Professor. You just said that it's impossible to have an actually infinite number of things. So why are you saying imagine a hotel that has an actually infinite number of things? Well, because, once again, in order to show you that it is impossible to have an actually infinite number of things, I want to start from the assumption that it is possible and show you that it is so absurd that it is impossible. So let's assume, just for the sake of argument, that you have an actually infinite number of things. We can do this with stamps, with coins, with whatever you want. But since I'm explaining Craig's paper, and he uses the Hilbert's hotel, let me explain the Hilbert's hotel, because you read about it, and it might be confusing. So, again, let's assume that a hotel exists that has an actually infinite number of rooms. In addition to that, imagine that there is like here in the illustration, there's no vacancy. There's no vacancy. Every single room of this hotel is occupied by a guest. And at the same time, you notice something bizarre here, because the sign says no vacancy, but guests welcome. But how is it possible that guests are welcomed if all the rooms are occupied? Well, here's how this hypothetical proprietor of this Hilbert's hotel would accommodate more guests in a hotel that has no vacancy whatsoever. Suppose you need a room and show up, ask for a room. Instead of sending you away to another hotel, the proprietor says, "Don't worry, I'm going to make some arrangements and find a room for you." So all he needs to do, since there are an infinite number of rooms, an actually infinite number of rooms, the proprietor moves the guest in room number 1. He asks gently, "Please do me a favor. Move into room number 2. And the one in room number 2, please move in room number 3. And the one in number 3, please move in room number 4. And you get where this is going, right? So by shifting all the guests, naturally, now there is a vacancy, room number 1. And you have a new guest accommodated in room number 1. This is bizarre because you had no vacancy. We started with no vacancy. Okay? Here's the thing. Here's how bizarre it is. We started with no vacancy. We found a new room for the new guest. How many guests do we have prior to the coming of this new guest? An actually infinite number of guests. Okay? Now, how many guests do we have now after the new guest comes into the hotel? Well, the answer is still an actually infinite number of guests. But this is very odd because we added 1 to an infinite number of guests. So it's infinity plus 1. And the answer is still infinity. In fact, you can do this many times. You can do this 100 times. Okay, just by shifting rooms shifting guests in different rooms, you can accommodate any number of guests. 5, 10, 100, a million, trillion. And what's odd about it is that I don't care how many guests you add, I don't care how many guests you accommodate. The final number of guests is still an actually infinite number. So even if you add 3 trillion guests, 3 gazillion guests, plus infinity, you still have an actually infinite number of guests. That's very odd. Now, as if this were not enough, crazy enough, let me tell you what happens when you actually add an actually infinite number of guests. So, again, imagine the hotel, no vacancy, an actually infinite number of rooms, an actually infinite number of guests. Now, all of a sudden, there is an actually infinite number of guests who need a room right now. Well, it is possible to, once again, to arrange the guests in a hotel in such a way that you free up rooms for an actually infinite number of guests. That's easy. Take guests in that occupies room number 1 and you move it into room number 2. The one that occupies room number 2, you move it into room number 4, and so on. So in other words, you arrange the guests, you move guests in such a way that you free up the odd numbered rooms. So all the because think about it, how many even numbered rooms exist in this hotel? Well, the answer is an actually infinite number of rooms. So if you have an actually infinite number of guests, you can take the guests that occupy the odd numbered rooms and shift them into the even numbered rooms, thereby freeing up all the odd numbered rooms. Following? And so by doing that, now you have all the odd number rooms completely empty. And voila, you now are able to accommodate not many, but an actually infinite number of guests. And once again, we added an actually infinite number of guests into to an actually infinite number of guests, and still we have the same result. We have a total of an actually infinite number of guests. So what's odd is that the number doesn't change, but we just added an actually infinite number of guests, but the number doesn't change. Now what gets even more strange, even more odd, is if you were to subtract, so to take guests out of the hotel. Think about this. What if you take 1 million guests out of the hotel? If they check out, what happens? Well, you still have an actually infinite number of guests. So infinity minus infinity is still infinity. What if you take all the guests that occupy even numbered rooms, 2, 4, 6, 8, 10, and so on, all the way down to infinity. They all check out. How many are they? An actually infinite number. So you subtracted infinity from infinity. And what do you get? You still get infinity, because you still have the guests occupying the odd-numbered rooms. And so, did I say correctly? So you remove the guests in even-numbered rooms, you still have the guests in odd-numbered rooms. How many? Well, an actually infinite number, right? So infinity minus infinity equals infinity. But now, think about this. Now, only guests from in room 1, 2, 3, 4, and 5, in these 5 rooms, these 5 guests decide to stay. And starting with the guest in room number 6, all the way down to infinity, all these guests decide to check out. So now, how many guests are we subtracting? Are we removing from the hotel? From 6 to infinity, how many? Well, an actually infinite number of guests. And once you have removed all these guests, how many guests are left? 5. Okay. So infinity minus infinity is infinity. Infinity minus infinity minus infinity is 5, because we remove an infinite number of guests and we have 5. But in fact, it's confusing, because you can do infinity minus infinity, and it's infinity. Infinity minus infinity is 5. Infinity minus infinity is 0. So you get a variety of results. Now, what's the conclusion to this experiment? This experiment clearly shows that the absurdity of any collection, whether it's a room in a hotel or whether it's stamps. You can do the same thing with stamps or coins or CDs or anything. This experiment, this thought experiment, shows that it is impossible. It is impossible to have any collection in the world that has an actually infinite number of members. Now, if you say that it is possible that an actually infinite number of things, a collection that has an actually infinite number of members, can exist, it is possible, then you have to deal with this paradox. You have to deal with the Hilbert's hotel. You have to deal with this thought experiment and explain how it might be possible that this might happen in real life. That infinity, when you add infinity or subtract infinity, you have either infinity, you have any number, from 0 to infinity. That's clearly absurd. It clearly shows that it is impossible. So if you accept the possibility of actual infinity, you accept the possibility of a hotel like the one I described. Okay? But clearly, it's not impossible. It's not possible. Now, once again, why am I talking about a hotel since we are talking about the universe? But naturally, because the number of rooms in the hotel represent the number of days in the past history of the universe. So, if it is possible to have an actually infinite number of things, or a collection that has an actually infinite number of members, then by the same token, it is possible to have an actually infinite number of days in the past history of the universe. But since it is impossible for a hotel, for any collection, stamps, CDs, coins, then it must be impossible for a collection of days. And consequently, the conclusion to this argument is that the universe is finite. The universe is not infinite. Or, in other words, the number of days in the past history of the universe is a large number, but it's finite. So the universe began to exist at one point. A long time ago, sure, I granted that, but it began to exist. There was a day one. The history of the universe does not stretch back for infinity. It starts at one point. This is what the argument shows. I hope this was clear enough. Well, now, in order to make even more powerful this argument and to support premise 2, remember that what we're doing here is to support premise 2. Premise 2 says the universe began to exist. So if I'm right about this Hilbert's hotel thought experiment, no collection that has an actually infinite number of members exists. Since the universe is a collection of days, it follows that the collection of days in the past history of the universe is not infinite, is not actually infinite. It's going to be a large number, but not an actually infinite number. So the next argument, because there is a next argument, it's slightly different. Well, actually, no, it is quite different. It's very different from the first argument. But it still has to do with collections. So I don't want you to get confused. This is a different argument. The first argument says an actually infinite number of things cannot exist. The second argument that I want to show you is that an actually infinite number of things cannot be created by adding one thing at the time. I don't really understand why Craig needed this argument. This argument is really useless to me, because it is clear that, well, maybe it's clear to me. Maybe it's not clear to other people, but it's clear, very clear to me, that no amount of time will allow you to acquire a collection of any items that you want, stamps, coins, or days, for that matter. No amount of time will allow you to do that. Because think about it. There are two problems. One I illustrated earlier. Let's say that you have an infinite amount of time. You are immortal, and the universe will go on forever. Now you decide to collect stamps. So you acquire stamps, as I said earlier, but you will never get to the end of the collection. I mean, unless you say my collection should be 3 trillion stamps. Okay, but that's going to be a finite number. Okay, now, in order to make it an infinite number, you will have to go on forever and ever and ever. But the problem is that you will never get to the end. You will never get there. There's no such thing as an infinitieth number, where you buy the last stamp, the one that makes your collection of stamps actually infinite, the infinitieth stamp. It doesn't exist. You can always add one more. You can always buy one more and acquire more. That's a fairly simple problem, so we don't even need this argument, I guess. I don't need it. Now, the second point that I wanted to make is the following. Think about just the absurdity of an actually infinite number of days. So once again, if the universe never began to exist, is eternal, like many people like to say, what does that mean? It means that, well, which is day one of the universe? Well, if you think that the universe is beginningless, obviously you believe that there is no day one of the universe. Am I right? There's no day one. It just stretches back forever and ever and ever and ever. But then, just think about it. If the universe never begins, how do you explain the fact that we are here? Some people might say, well, just if you're patient, give it time, and eventually you will get here. But that's impossible. Just think about it. It's impossible because you never start, you never begin. How do you even get to this point? So from infinity, how long is it going to take you to get here to today? Boy, it's going to take forever, because you have an actually infinite number of days to get here. In other words, you will never get here. Okay? So the fact that we are here, the fact that there is a present moment, a present time, implies that there was a beginning. Without a beginning, you cannot move and cross and transverse, as the medieval formulated the argument. You cannot cross this huge amount of time. I mean, it's not even huge. The point is, it's infinite. So how long is it going to take you to go through an infinite number of days? Well, literally an infinity. Or in other words, you will never get through, because they are infinite. And so that doesn't make sense with the fact that we are here. We are here. The present day, the present time exists. We are here. So in order for us to be here, we had to start from somewhere. The universe must have started, must have began at one point. Otherwise, we will never get here from infinity. And so even this second argument, the argument from that says an actually infinite number of things cannot be created, it seems obvious, as I said, to me. You cannot create any collection by adding one member at a time and make it into an actually infinite number of members. So this applies to the universe. The days of the universe cannot be infinite, actually infinite, by adding one at a time. And again, the problem is that if you don't start your collection anywhere, then you will never finish it. If you don't start, if the past of the universe stretches back forever and ever and ever, you will never be able to get here, because it will take you an infinite amount of time. In other words, literally forever and ever and ever, and consequently, you will never get here. You will never arrive at the present day. So the existence of the present day implies that there was a beginning of the series, a beginning, a day one of the universe. That's what the argument shows. Okay, so I talked about two arguments so far. The first argument, and remember, once again, these two arguments are supposed to support premise 2. The universe began to exist. So, according to the first argument, since an actually infinite number of things cannot exist, then the universe cannot be an actually infinite number of things. Consequently, the universe must be a finite number of things, events, days. The second argument is that it is impossible to acquire an actually infinite number of things by collecting one thing at a time and adding, because you will always be able to add one more to your collection, one more item to your collection. And also, if you don't begin, you will never end. And consequently, also, this argument, the second argument, shows the same story, that the universe, since the universe is a collection of days, the collection cannot be infinite in itself, and it cannot be infinite by adding one day after another. Okay, that's impossible too. So the conclusion is that the universe must have a beginning. But since people are not easily convinced by logical arguments, let's look at a third argument, a scientific argument, because everybody likes science. Everybody thinks that science tells you the truth about the universe. How can science be wrong? Well, in fact, science has been wrong many times. But the point is, it is very remarkable when you think that you have two independent philosophical arguments, two logical arguments, that lead to the conclusion, the same conclusion, that the universe had a beginning, a day one. And it's, as I was saying, remarkable that also independently, quite independently, the best scientific argument that explains the origin of the universe, namely the Big Bang Theory, says that the universe began to exist. Now, I'm not going to give you a lecture in physics or in astronomy, not that I am qualified to do it, but what we have to remember is the following. The Big Bang Theory is the best explanation of the universe. The best scientific explanation of the universe. And the Big Bang Theory says that 13.8 billion years ago, a singularity occurred, and this singularity expanded violently, rapidly, and formed space and time, and everything that we can see in the universe. So, what's prior to 13.8 billion years ago? The question is. Well, according to scientists, there is nothing, according to them, prior to the... How do they know there was nothing? Well, it's pretty clear, because if the universe is what we call space and time, obviously, prior to the universe, there is no other universe. There's no space and time. But how do you know? Maybe there's another universe. Well, that's impossible. That's not what science shows. According to scientific evidence, the universe itself is space and time. So there cannot be any space and time prior to the universe. Now you say, but maybe there is. Okay, but fine. If there is space and time prior to this universe, then you still have to explain why there's space and time in that universe. And I think you you're going to have to explain it in terms of a third universe that has space and time and generates the second universe that generates our universe. But then naturally, you're going to have to ask, but what universe, or maybe there's a universe prior to the third universe that we said, and that's the universe that brings into existence the third universe that brings into existence the second universe that brings into existence our universe. And I think this is going to lead to an absurdity that we ruled out by our philosophical arguments. Namely, it is impossible to have an actually infinite number of universes. So at one point, there must be the beginning of the universe. So the Big Bang Theory essentially says the universe is expanding. As I mentioned in the first part of the first video, there is a pre-established theory, the Bohr-Guth-Vilenkin theory that says that any universe that is expanding, like our universe, has a beginning. It's not eternal. It's not beginningless. Also, I wanted to remind you, I'm sure you know who Stephen Hawking, one of the greatest physicists ever existed, was that man on wheelchair that you would see on History Channel or Science Channel and so on. He himself said that accepted that the universe began to exist, although before he died, he was working on a alternative model that would explain how the universe is infinite. And we're going to talk about that in a minute. But essentially what I'm saying is that Big Bang Theory, I know that some people will dispute this and will say the Big Bang Theory doesn't say that there was nothing before the universe. Well, what I would ask to these people is the following: if you argue that there was something prior to space and time, what was there? Because if you don't have space and if you don't have time, what could possibly exist? Well, essentially nothing. And that's the idea of the Big Bang. But again, some people dispute this. Physicists, some physicists as well, dispute this. But it seems that there's nothing essentially prior to space and time. So anyway, how do we address this problem of the Big Bang? Many contemporary scientists, many contemporary cosmologists and physicists are starting to doubt the Big Bang theory. What they're saying is that there was a mistake. There must be a mistake. That Big Bang theory, it relies on classical physics, and classical physics, as you know, or if you don't know, classical physics essentially, the problem is that does not square well with quantum physics. So several physicists today, several scientists are starting to wonder whether the Big Bang theory is in fact the best explanation. So over the years, over the decades, many different models, alternative explanations for the existence of the universe have been proposed. Now let's start with the easy one. The steady state. The steady state is no longer a serious theory considered by physicists because after 1965, two scientists that worked for the phone company, Penzias and Wilson, they discovered a background radiation that indicated a violent explosion and the aftermath of the explosion, the expansion of the universe. And prior to that, in 1929, Edwin Hubble, the one whose name was used to name the Hubble telescope, Edwin Hubble discovered that the so-called red light shift. The red light shift essentially is, you can look it up on Wikipedia, but let me explain it to you just very quickly what it is. The way that we measure the distance of galaxies is by determining the red light emanated by the galaxy. Okay, so depending on how far a galaxy is, it will emit a red light of a certain shade. So the darker the shade of red, the farther away the galaxy. And so when Hubble discovered that the same galaxies, when you observe them at different times, they tend to emit a redder color, a darker color. That indicates that the universe is, in fact, expanding. It's moving away in all directions. And so nowadays we know that the universe is not steady. The universe is expanding. So if the universe is expanding, as I said earlier, according to that theorem, the Born-Guth-Vilenkin theory, we know that if it's expanding from something. And the singularity, 13.8 billion years ago, is the point from which the universe started expanding out of nothing. Now, the singularity is not a speck of dust. It's a point. It's like a mathematical point. It's a conceptual point. And so prior to singularity, there's absolutely nothing, because the singularity is what brought into existence space and time, as I said. And so before space and time, there is no space, there is no time. It would be absurd that there is space and time before space and time. So the steady state is no longer an explanation, a good explanation. There's also another explanation, the oscillating theory. This says that the universe oscillates, so like a rubber band. It stretches and retracts and crunches back like a rubber band. Okay? It stretches back and forth, and this has been going on forever. Okay, but there are two problems. One is there are no observations of such a thing, and also there's no indication in the universe at the rate at which it's expanding, and all observation. There's no indication that the universe will eventually collapse. And secondly, another problem is that this back and forth of the universe. Remember that the universe contains space, time, and a lot of stuff, a lot of planets, a lot of stars, and so the disorder and the anomalies and the actual tears in the fabric of space-time will be so egregious that there's no explanation as to how the universe can actually stretches back and forth like that without creating disorder that we clearly don't see in the universe. Another explanation, another alternative model, is the so-called bubble universe. So imagine that our universe is just one in a collection of an actually infinite number of universes, like a bubble in a bubble bath. There are just so many. Our universe is the one that made it, is the one that contains human beings and life. But this model does not explain why there is a universe in the first place. So you can ask the same question about our universe to the bubble universe, the ensemble universes. Why is there an ensemble? Why are there bubble universes? Now, the last one that, at least that Craig mentions in his paper, is a quantum model. Now, this is very complicated, and I don't think even Craig is able to explain it clearly and correctly. But the point is the following. The quantum model of the universe is a model that explains how the universe does not begin to exist. And it does that by postulating that as you approach the beginning of the universe, time rarefies, time disappears. And so if there is no time, there's no beginning, right? If I say to you, let's assume that the time doesn't exist. Time doesn't go on. Time doesn't exist. So if I say to you, you were late, what do you mean late? There's no time. Late relative to what? And if I say, when did you begin, say, eating dinner? But if there is no time, you never began, essentially, because there is no time. You always begin or end any measure, any parameter, any way you want to put it. You need time. We begin or end relative to time. So if there is no time, there's no beginning. And and this might explain why the universe is beginningless. But in fact, well, you have several problems. One problem is that you have to deal with the Bohr-Guth-Vilenkin theory that says that the universe that is expanding has a beginning. Now, the way the quantum model deals with that, the Hartle-Hawking model, is that time doesn't exist. But the way they arrive at this conclusion is really a mathematical process, and so they employ what is known as what is known as imaginary numbers. Now, if you are not into mathematics and you don't understand these concepts, I want to say imaginary numbers are not like numbers given by Santa Claus or the leprechauns. Imaginary numbers is a concept in mathematics. They are numbers used to do certain calculations. An example of an imaginary number is the square root of a negative number, which is impossible. I mean, not impossible, but typically you square root positive numbers. So these numbers figure in a calculation that leads to the conclusion that the universe is timeless, that time disappears. The problem is that imaginary numbers do not describe the physical world. And if you want to describe the physical world, you must translate the imaginary numbers into real numbers. But once you do that, then time comes back into the picture. And so I remember Stephen Hawking, saying that in one of his books that the Kalam argument is a serious problem, because if there is a beginning of the universe, then you can't avoid the fact that there must be a creator of the universe. And so that's why he tried to propose an alternative model. Now, you can say to me, but he was right. He was right. So the Hartle-Hawking model is correct. So the universe does not begin to exist. It's like almost thinking about a sphere. When you take a sphere, you can point your finger anywhere on the surface of the sphere, and you can say, I mean, every point is equivalent. There is no beginning, okay, in that sense. So if you can imagine the universe, something like that the universe is self-contained, so to speak. It's like a sphere that has no beginning. Every point can be the what we call the singularity, but in reality is just a point that belongs to a whole, if that makes any sense. The problem is that while it's an interesting theory, it is not the accepted theory. It is not the current theory, the best explanation. Over a long period of time, that scientists have been trying to explain the existence of the universe by means of alternative models. Unfortunately, I have to say, fortunately or unfortunately, they have failed. And the Big Bang Theory, it's still undefeated. It's still the best explanation that we have of the universe. And what does the Big Bang Theory say? Well, it leads to the conclusion that the universe began to exist. Okay, so we have three arguments. The first argument proves that there is no collection in the universe that has an actually infinite number of members, including the universe. The second argument proves that there is no collection that has an actually infinite number of members by adding one member after another member. The third argument would be the Big Bang Theory, okay? And this is where the fun begins. Because it seems to me, at least it seems to Craig, that whatever begins to exist as a cause, that was the first premise of our argument. The second premise, and that we said that was true. Now, we needed to establish whether the second premise was true, that the universe began to exist. And according to three arguments, the two logical arguments and the scientific argument, it is true that the universe began to exist. Now, once again, is it possible that that the universe did not begin to exist? Because after all, for all you know, the universe is so bizarre that maybe it's eternal and we don't know. Sure, there's always a possibility. And you can say, well, haha, and you maybe you caught me on one of those aha moments. But the point is, it might be conceivable, it might be possible, but But really, is it plausible? We have three arguments that independently show that the universe began to exist. Now, is it more plausible that the independent arguments and our observations are wrong, and the assumption that the universe began to exist out of nothing? And the assumption that the universe is eternal is plausible? Well, it seems to me that there's no evidence. All the evidence is in favor of a finite universe, not an infinite universe. So perhaps it's possible, but there are no arguments, no alternative models. It doesn't make sense mathematically, it doesn't make sense logically, it doesn't make sense scientifically. So what's more plausible? So I want you to understand, once again, in the case of premise one, it's a matter of how plausible, the level of plausibility. And it seems that these arguments are more plausible than, so the second premise is more plausible than the premise that the universe is infinite. Okay, now, here's where the fun begins. We just established that the universe has a cause. Or, again, if you want to free the argument from causation or causal relation, we can say that we just established that the universe was created by something else. Because, why? Because whatever is created, whatever begins to exist, whatever is created, has a creator. Something or someone who, or that, brings that into existence. So we just established that. Okay, fine. But we don't know what it is. It could be anything. It doesn't have to be God. It doesn't have to be a person, especially. It doesn't have to be an entity with an intelligence or an entity with a mind. But let's see what we can say intelligently about this first cause, or this thing that brings the universe into existence. Here's what we can say. First of all, this such a creator of the universe must be something or someone that did not begin to exist himself or itself. But wait a minute, Professor. This is not fair, is it? Because you're thinking, you just said that everything that begins to exist was brought into existence by something else. So now you're saying that the cause of the universe, the creator of the universe, was not brought into existence by anything else? Yes, but that's not an error. Think about it. The argument, the Kalam argument, says that everything that is created, everything that begins to exist, has something else that brings it into existence. But the argument does not preclude the possibility that there are things that are uncreated, things that are eternal. It's just not the universe eternal. But the cause of the universe, naturally, if the universe, we established that the universe was created, began to exist. Naturally, the thing that brings the universe into existence cannot said to be a created thing, because if it is a created thing, what created that thing? Well, it must be something else. But what created that something else? You see where we're going here. This is going again to the same puzzle to the same paradox of infinity. You cannot postulate an actually infinite number of creators. And so at one point, you're going to have to decide and say, I see, there's no other solution. There must be a first creator. And what created that creator? Nothing created that creator. Otherwise, you go back to infinity. And that's impossible. And it would take forever to create the universe. So we know that the universe, by logical necessity, the cause of the universe, the creator of the universe, must be uncaused. No one caused it. It must be eternal. Also, we know by definition that if the universe is described as space and time, naturally, whatever created the universe does not exist in space and time before he creates space and time. First, he creates space and time. But before that, there is no space and time. So, the creator of the universe is timeless and spaceless. It means that it transcends time and space. And consequently, it must be non-physical and immaterial. Also, we know that it must be very powerful. I mean, if it really brought the universe into existence out of nothing, clearly it must be very powerful. And the last and the most important characteristic of this creator on the list is that it must be a person. Now, don't get alarmed. When I say person, I don't mean a person in the sense of human being, a person like you in that sense. When I say person, personal, I mean that it must be an intelligence. It must be something that thinks and makes decisions. What's the alternative? Well, the alternative would be a mechanical process. Anything mechanical that and brings the universe into existence. So I guess if you have come so far and you accepted the argument, the Kalam argument, the last resort for you to deny the existence of a personal creator is to say that there maybe you're right, there is a cause of the universe, but that cause is impersonal, it's mechanical, it doesn't know that we're here, it doesn't care, didn't make a decision to create the universe. It's just like growing hair, it's like a tree growing branches. It's just a mechanical, natural process. That's the way it is. But I want to show you that this position, namely the position that the creator of the universe is a mechanical process, an impersonal process, is problematic, if not absurd. Let me try to explain how and why. William Lane Craig, in his paper, gives the example of temperature. So he says, imagine that, not imagine, the freezing temperature of water is 0 degrees Celsius. I think it's 32 degrees Fahrenheit. Am I right? You correct me if I'm wrong. And so I guess that's a pretty good explanation of a mechanical process. Temperature goes down to 0, water freezes. Okay? So if you ask, what brought into existence this change, the water was liquid, now it is frozen. Okay? And you have to answer a mechanical process. And that process is that the temperature went down to 0 degrees Celsius. So imagine a big room, and there's a glass of water in the room, and there's a thermostat. I can adjust the temperature. Now the temperature is, say, 2 degrees Celsius or 3 degrees Celsius. The water is not frozen yet. The water is still liquid. It's very cold, but still liquid. Now, imagine that I adjust the temperature and I turn down the thermostat to 0 degrees Celsius. Now what happens? What happens is that the temperature of 0 degrees, as the room reaches that temperature, 0 degrees, 0 degrees brings into existence a change, an effect. And that effect will be that water is freezing. So you will have frozen water. Now, suppose that instead of the thermostat and my adjusting the temperature from 3 degrees Celsius to 0 degrees, suppose that the temperature inside this room has been 0 degrees Celsius from eternity. And again, there's water, there's a glass of water in that room. Ask yourself, when did the water begin to freeze? Seems clear to me that if you put it that way, the water has been frozen forever, from infinity. Because you remember, it's just a mechanical process. When the cause is present, then the effect must occur. So if the temperature goes down to 0 degrees, automatically it brings a change, an effect. It brings its effect that it exerts its power, its causal power upon the water, and it freezes the water. That's the way mechanical processes work. You have the cause, and there's the effect. So now, what's the problem here? Well, the problem, think about it, is that in our case, we are talking about the universe. The universe is finite. The universe began to exist. But the cause of the universe is infinite, is beginningless. So it is the same, and this is the analogy with the second example that I gave you, where in the room you have 0 degrees Celsius from eternity, and the water is frozen also from eternity. Because if the effect is there, if the cause is there, the effect must be there too. So when we use this analogy and we apply it to the universe, it's a puzzle, because if the cause of the universe is a mechanical process, and this mechanical process has existed from eternity, then what do you expect? You expect that the universe would be in existence from eternity as well. Because a mechanical process cannot decide when to exert its power, its causal power upon the effect. In the case of the water, the 0 degrees Celsius has no freedom to decide when to start freezing the water. As soon as the temperature is 0, the water freezes. If the temperature is 0 forever, from eternity, then the water would be frozen from eternity. So, by the same token, if the cause of the universe is a mechanical process and it exists from eternity, then the effect must be present from eternity. In other words, if the cause of the universe exists from eternity, the universe must exist from eternity. If the cause of the universe, whatever creates the universe, is a mechanical process. And so our problem is then to explain how it's possible that the cause of the universe is eternal, and yet, though it is eternal and present from eternity, it doesn't bring its effect about from eternity, but it brings its effect 13.8 billion years ago. Only 13.8 billion years ago. And so, what does this lead to? It leads to the conclusion that the only explanation is that the creator of the universe is a person endowed with intelligence and free will, capable of not exerting its causal power, because it is the creator of the universe, and can decide and say, now I want the universe to come into existence. But a mechanical process, you understand, does not have the liberty, the freedom to do that. Mechanical process says if the cause is there, if the mechanical process exists, the effect must be produced mechanically, naturally, necessarily. If the mechanical process exists from infinity past, then the effect must be present from infinity past. But that's not the case that we built with this argument. The argument shows that the universe began to exist. So again, the only explanation as to why the universe is finite when the cause of the universe, the creator of the universe, is infinite, is beginningless, is eternal, is that the creator of the universe has a mind and a freedom to begin the universe. So the conclusion is, as amazing as it may seem, I quote what Craig says, the most plausible answer to the question of why there's something exists rather than nothing is that God exists. Now, hold your horses. How do we get from the cause of the universe to God? Well, simply, Craig says, I like to call it God. You can call it a rabbit, you can call it Shmagad, you can call it whatever you want. But essentially, that is pretty much what we mean, religious people. When religious people describe God, that's essentially what they mean. They mean a super powerful being endowed with free will and capable of bringing the universe into existence out of nothing. And so that's the idea of God. Not any particular God, as I mentioned in the previous video. but a personal God. Now, the very last part, and I'm going to be very brief here. The very last part of the paper that you read is remember, the Anthropic Principle. The Anthropic Principle is very complicated, but I'll try to explain it very clearly and succinctly. The Anthropic Principle is, so Craig needs that little bit at the end because here's the problem. One might say, okay, we established that the universe has the universe began to exist. The universe has a cause, has a creator. The creator of the universe is not a mechanical process. It is a godlike creature. But the last resort of the atheist is to say, but this God, we don't know if he cares about us. We, for example, might be an accident, or even the universe might be an accident. Okay, so let's say maybe this is not a good God. It's a crazy God. It's a crazy entity that, who knows, just stumbles upon things and is clumsy, and as a result, you have the universe. Or maybe it's just an experiment, and who knows? In other words, it is possible that then this God is not really concerned about us, and the universe is just a mistake or an accident. So the last part of the essay, Craig explains the Anthropic Principle, which is, when you look at the universe is not random. It's not a random thing. And especially considering that there is human life, intelligence, we exist. In order for us to exist, you don't need any kind of universe, any old universe. You need a very specific universe, a universe that is exquisitely tuned and designed in such a way that it will generate human life, generates intelligence, generates us. So that will indicate that God, this creator of the universe, was not an accident. It was not a mistake, but he had in mind specifically the universe in a very specific way in order to bring into existence us. That's the idea. Now, why do I say that? Because the Anthropic Principle is based on a concept known as the fine-tuning of the universe. And essentially, let me explain it. It has two aspects, the fine-tuning, or the Anthropic Principle. First of all, the first aspect is that in order for a universe like our universe to exist, you need a very specific values, very specific numbers. In other words, scientists argue that if you were to change anything about the initial expansion of the universe, the Big Bang, a singularity produced this expansion, expanded into the universe, while in the very first period, a short period of time, you don't need to know the names, you can look them up if you're interested, but in an early period of time, the baby universe, let's call it baby universe, perhaps did not contain time. Some people might say it was very dense and it was very hot, but not hot like the stove, a heat that we can't even fathom. And at this point, nothing really exists, obviously. There's the expansion, there's the heat, extreme heat of the universe. But that very temperature, that very heat and the velocity of the expansion and everything that is happening at this point is crucial, because if you were to change anything, the velocity, for example, of the expansion, or the temperature, the density, as a result, you have no universe at all. Either you have no universe, or you have an empty universe where stars don't form. And as you know, stars created the elements that created life, human life. All the chemistry, all the bonds, everything in the universe will not be able to be created. When you think, for example, of an atom and how the relationship between the atom and the subatomic particles, how they stick together, how they glue together. Okay, there are certain they are very precise the way they're made. If you move the neutrons or the protons somehow by a very small magnitude, if you change any of these things, any of these values, then what happens is that, well, atoms cannot even form. Elements cannot form. So you don't have any universe at all. And so in order to create this kind of universe, you have to preset a nexus, a complex nexus of values and parameters and situations that allow, that permit the universe, this kind of universe, to exist. Secondly, the second aspect is that now that the universe, once the universe is formed, then you need certain laws, the constant laws of physics, like gravity, the weak force, the strong force, electromagnetism, all that stuff, all the constants in a universe must be very precise, because if they were different just by a small magnitude, once again, you were not able to have life. And so Craig's argument in the Anthropic Principle is that when we observe the universe, it is remarkable that every single piece of the universe, every single parameter, every single function, every single force, every single law, and the very way in which the universe unfolded from the singularity, they all point in the same direction. The direction that all this, even the, by the way, even the very dimension of the universe, all these things are necessary in order for the Creator to create us, to create intelligent life. And so for that reason, it is not an accident, according to Craig, that the universe exists. Not only was the universe created by a deity, by something that we might call God, but also this God had a pretty clear plan, idea in his mind when he created the universe, because he created it in such a way that we would exist and we would be rational and understand its creation. And so I think pretty much this is ends the lecture on the Kalam cosmological argument. And so it's a very interesting argument. I can't wait to, I'm really looking forward to discussing this in the discussions page, in the discussion board. I can't wait to hear from you, your thoughts. What do you think about the Kalam argument? And also my viewers, by the way, not only my students at the City University of New York. If you have questions, you can contact me. You can find my email easily online. I'm famous. You can find me online. But anyway, you can use my City University email, which is C Alvaro, the letter C, last name Alvaro at cdtech, one word, cdtech.cuny.edu. You can email me. Feel free to email me and ask me questions. I'm more than willing to answer all your questions, to discuss this argument further. So for now, I'm talking to my students. Thank you very much for watching this video. And this concludes the lecture on Kalam cosmological argument. Don't forget to post your questions, answers, and comments in the board. And I'll see you next time.